Okay. We already did. I know we already did this. Well, that's.
Well, you didn't know what we were doing today. So.
Oh, okay. All right. Don't fight. Don't fight. All right. So yesterday we learned about the third and the fourth types, reaction types. The third being combustion. What in hydrocarbon combustion? And then the fourth type is single replacement, when one thing kicks out another. And the one single replacement that I'm going to do to warm us up a little bit is pretty fun, pretty common. I'm going to take some zinc metal. I'm going to take some zinc metal and I'm going to add it to some hydrochloric acid, which is hydrogen chloride when it is aqueous. And that's going to be a single replacement. So in a single replacement, one thing kicks out something else. What's going to do the kicking out? Zinc. What's going to get kicked out? Hydrogen. So we're going to make zinc chloride and we're going to make hydrogen gas. And the hydrogen gas is going to go bubbly, 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 bubbly. Let's see. Ooh. Let's try the... I'm feeling like a blue day today. I feel like blue. Blue's, I think, our winner. Very blue today. Evidently you can. When are we going to do what? Bingo. Play bingo again? I don't know yet. Never ever again.
Are we gonna make gunpowder in class?
Yes. Okay, so I got my zinc in the bottom of my flask, and I'm going to add some acid to my flask. And if all goes well, I will be able to capture. I'll be able to capture the hydrogen gas that's zooming out of here in a balloon. Probably. I mean, balloons do tend to do that. There we go. This is what we call an exothermic reaction. The reaction produces a lot of heat. So to keep the glass kind of cool, I make a little water, a little bit of water on a paper towel and stick it on the paper towel to keep the glass a little bit cool. The water will absorb some of the gas. Okay, so while this is doing its thing, and it's doing its thing, a hydrogen gas is being produced and we're capturing it. Is this something you can balance?
Yes.
So why don't you go ahead and balance that? You already did. Some of you were like, I'm so cool. Okay. So Ellie, you already balanced it. What did you do to balance it?
I put a 2 on the zinc, 2 on the HCl.
You put a 2 in front of the zinc and a 2 in front of the HCl? So you put a 2 there and a 2 there?
And then I put a 2 in front of the zinc chloride.
A 2 in front of the zinc chloride? Okay, let's take a look. 2 zinc, good. 2 hydrogen, good. 2 chlorine, 2 chlorine. Hey, it's balanced. Well done, Ellie. All right, now I'm going to let that cook for a little bit. We have to move a little fast because hydrogen is a very small molecule, so it's leaking out through the pores of the rubber as we speak. So we don't want to wait too long. But I do want to talk about what I'm about to do. I'm about to do a synthesis reaction. I'm going to take the hydrogen gas and I'm going to heat it up and allow it to react with oxygen gas. And guess what it's going to make?
Fire.
Yeah, and what else?
Water.
Water. Yeah, it's going to make water. It's going to make fire and water, and the water is going to be gaseous. Is this something you could balance?
Yes.
Then balance it.
Sir, yes, sir.
You guys can do all the practice without even having paper? Wow. That's stupendous. Ellie, would you like to light this on fire? All right. Would you like to light it on fire? Ah, it's hydrogen. Ah, it's hydrogen. So, are you going to die? Well, yeah, but it has nothing to do with what happens today. Then that'll be the first I've heard of it. Don't go away. All right, you got some glasses?
No.
Definitely gonna need some glasses. And we're also gonna need to refill our fire pencil. You guys are fortunate. The fire pencil died yesterday, so I had to put in a separate fire pencil. Because I needed to make a flame. Yeah, you'll see there's a very important reason that we want to stay away from that bubble. Okay, I'll light it back on. I know. These $4 fire pencils aren't what they used to be. Whenever you're ready.
Obviously.
Thank you. Okay. You should have seen what happened first period. I don't know exactly why, but the balloon got like this big, and the fireball was like gigantic. But sometimes science just is unpredictable. All right, so Landon? Excellent. I was going to ask you, can you bounce it? Bounce it?
2 in front of the H2.
2 in front of the H2?
2 in front of the H2.
Okay, so Landon thinks he got this one balanced. Let's see if he's right. We'll come back to order, please. All right. So we got 2 by 2 for 4 hydrogens, 2 by 2 for 4 hydrogens, 2 oxygens, 2 oxygens. Looks balanced to me. Pretty cool. Okay. So that's a good warm-up. The last basic reaction type that we're going to talk about is called a double replacement. In a single replacement, one thing kicks out one thing. In a double replacement, the things switch partners. So A and B break up, and A reacts with D, and C reacts with B. The important thing to realize is the A is still positive, the B is still negative, the C is still positive, the D is negative, the A is positive, the D is negative, the C is positive, and the B is negative. Okay. I did not use enough acid. There's still lots of zinc left in there. C'est la vie. So we're going to do a couple of double replacement reactions that I enjoy. The first one, I think, is this is the first time I've done this, actually, this year. And it's a chemical that I had in high school, because you can buy it in a hardware store. I'm not going to tell you what I did with it in high school. It's a very strange chemical, and the chemical is called calcium carbide. The chemical is called calcium carbide, and it has a very strange formula. It's CaC2. It's like little stones, but it's a very, well, it doesn't react well with water. So when it reacts with water, when it encounters water, it creates a double replacement reaction. Hey, those of you here yesterday, you know why I wrote water HOH, right?
Yeah.
Okay, because water likes to behave sometimes like an H+ ion and an OH- ion. So when calcium carbide reacts with water, calcium carbide, of course, being a solid and water, of course, being a liquid, it swaps places. So calcium is the positive and currently bound to the negative carbide. So the calcium is going to swap places So it's not going to be connected to the carbide. What is it going to be bound to? Yeah, the hydroxide, right. It's going to be bound to the hydroxide, and this is going to be aqueous. And then it makes a really interesting chemical. It makes hydrogen carbide. And it's not just any old hydrogen carbide. This is called acetylene. Acetylene, which is usually written C2H2. And it's a very strange chemical because it has a triple bond in the middle, which allows it to release a lot of energy, but it releases a lot of energy very slowly. This is what I accidentally burned in class last Monday or last week, where it made that cloud of soot.
Yeah.
Remember the cloud of soot?
Yeah, my paper.
Yeah, you can't remember the cloud. That's what I made. I was basically testing it out and practicing for today. We're going to do it in the fume hood.
I thought you had experience with this stuff.
I have lots of experience with the chemical, but not indoors. Yeah.
Okay.
We're not going to do it outdoors, so I'm just going to add some water to my my flask here. Oh, Moses, get up there, dude. Boom. And I'm going to get my hydrogen carbide, or my calcium carbide. I'm going to put it in a little dish. I'm going to take this over to the fume hood. Don't need much. Probably. We just bought it at a hardware. I don't know why. I don't know why they still sell it. But what it used to be used for, guys. You listening to something more important than your chemistry? Okay. You want to swap earwax, you just do your thing, as long as you're learning. Okay, so what this is was used for, is hundreds of years ago, before we had electricity and batteries, the miners, basically not you miners, but the miners that would like mine, hi-ho, they needed somewhere to see, somebody to see. So what they did is they had these crazy little lamps, and they had the calcium carbide in the lamps, and then they slowly reacted it, and the gas they collected was the acetylene, and they lit it on fire. And it was a pretty simple device. It was just a little can they carried. Sometimes you see them in video games. They're like, I got my lamp, and there's a little flame inside. Well, it turns out the acetylene, the H2C2, when it reacts with oxygen, it reacts in a hydrocarbon combustion. What are the two products of a hydrocarbon combustion? Yeah, CO2 and H2O. Remember, a hydrocarbon combustion talks about the hydrocarbon combusting with the oxygen to produce CO2 and H2O. And that's what I'm going to do in the fume hood. So as the acetylene is produced in the flask, I'm going to put a little cap on here. I'm going to light this on top, and a little flame's going to come up. And hopefully, that's all that will happen. So why don't you go ahead and balance this hydrocarbon combustion while I get prepared. So it sounds like some of you might have the correct answer. I'm hoping that is the case. All right. Who can raise their hand and tell me, I got the answer, I got the answer, I'm going to give you the answer? Oh, the usual suspects. Always the same people. Okay, Angelina.
A 2 in front of the
H2C2.
And a 5 in front of the O2.
A 5 in front of the O2.
4 in front of CO2.
4 in front of the CO2.
And 2 in front of H2.
And 2 in front of H2O. Okay, let's check our work. 4 hydrogens. 4 hydrogens. 4 carbons. 4 carbons. 10 oxygens. 4 by 2 is 8. 2 by 1 is 2. 10 oxygens. And it's good to go. All right. So here we go. Hopefully, all that will happen is we'll make a little miner's torch and we can like, hey, let's go mine our diamonds in the thing. So I put in the calcium carbide, we're making the acetylene, and le flame.
Right.
The funny thing is it started bright because there was oxygen in the flask. As the acetylene gas displaces the oxygen, then you get a nasty incomplete combustion, and that's where all the soot comes from. If you anyone ever done any gas welding? Yeah, students of the 21st century. Okay, so when I was in high school, we had gas welders, and you had 2 valves, one for the acetylene and one for the oxygen. And you started the acetylene up, and it went, that made this nasty flame. Then you added the oxygen, and it went, and it made this really awesome blue flame, kind of like this. All this is. Yeah. So all this is a. You guys are like, is that just a lighter? Yeah, it's just a lighter. So when you have a flame that burns oxygen very slowly, just oxygen comes into the end, you get this dancing yellow flame. But if you add oxygen ahead of time and basically give it plenty of oxygen, then you get a flame jet. Yeah, totally cool. You can buy these at Walmart, by the way. Totally. You're like, you had no idea all the dangerous things you could buy at Walmart or Amazon, huh? Okay, so that's a double replacement. There's another double replacement that I want to do. We got that. And here we go. I'm going to put some magic white powder in the bottom of this. Magic white powder in the bottom of this test tube. Get over there, Moses. There we go. A little magic white powder. And some more magic white powder into this test tube. Although a different magic white powder in this test tube. There we go. All right, so the magic white powder that I'm about to give Heidi is PbNO3. This is lead 2, guys. This is lead 2 nitrate. So I'm about to give that to Heidi, and then the magic white powder that I'm going to give to Taylor is potassium iodide, just plain old Ki. And these are both aqueous. I got goofy cues. Aqueous. So Heidi, here's your potassium nitrate. And Taylor, here's your, lead nitrate, potassium iodide. Okay. And these are going to undergo a double replacement reaction. See if you can figure out what they're going to make. PBK? PB. Remember, the positives always swap with the other positive.
Oh, PBI.
PBI, okay. PBI, and it's a 2+ ion, so we're going to make lead iodide, and we're going to make KNO3. the PBI is going to stay solid and the KNO3 is going to be aqueous. So go ahead and balance this if you wouldn't mind. Is it?
No?
I see one iodine on the left and two iodines on the right. Excellent. So a handful of people seem to indicate that they have the correct answer. Maybe someone who hasn't volunteered yet this week can tell me the answer. Justin, you haven't volunteered yet?
No.
All right, lay it on me.
All right,
2 in front of the potassium iodide. And 2 in front of the potassium nitrate. Okay, well, it's simple enough. 1 lead, 1 lead, 2 nitrates, 2 nitrates, 2 potassiums, 2 potassiums, 2 iodines, 2 iodines. Okay, ladies, as careful as you can, one of you pour your solution into the other person's test tube. What?
Maybe you mixed them.
Evidently I did. These chemicals should not go bad. Let's try this again. Oh, yeah, it's... That's why the potassium and nitrate hasn't got a chance to dissolve. Yeah, potassium nitrate didn't get a chance to dissolve. Let's speed the process up a little bit.
That's very yellow.
It's very yellow.
Pour it into this one. Yeah, it's very yellow now.
That went from not yellow to very yellow.
Yeah. Well, I'm sorry, that wasn't all that exciting because the potassium nitrate didn't get a chance to dissolve.
That was great.
But I'm glad you enjoyed it. Okay, wonderful. So what you're seeing is a really, really bright lead compound. Lead makes crazy bright compounds. And what you're seeing is the lead iodide. The lead iodide is forming tiny yellow particles. Question?
Is that why they make like paint out of lead too? So,
Used to, yes.
well, yeah, used to.
Yep. They used to make lead paints, lead-based paints, because the lead particles are very, very bright. And this is what we call a precipitate. It's called a precipitate because the little yellow lead particles, believe it or not, are actually settling to the bottom. They're heavy. So I'm going to set it right here, and by the end of the class period, there's going to be a whole bunch of lead iodide at the bottom, and a little bit up top, but most of it will be at the bottom, because the lead iodide is precipitating out of solution. You can already see a little bit at the bottom. I have one more for you. It's one of my favorites.
Is it gonna explode?
No, but you still might think it's pretty cool. When an acid and a base react, they undergo a double replacement reaction called a neutralization reaction. And I'm going to take concentrated hydrochloric acid. Guys, concentrated hydrochloric acid is not fun. When it comes from the factory, from the chemical factory, it comes very concentrated. I have to dilute it for you because the vapors will basically annoy you. I have to do everything in the fume hood where the vapors go up. But we're going to take advantage of that vapor And we're going to allow it to become gaseous, and we're going to react it with an equally concentrated base, which is ammonium hydroxide. And we're going to let it be more or less gaseous too. And something interesting happens when an acid and a base react. They make water. Plain old water. Yeah. You learned this in elementary school or junior high or last year. When an acid and a base react, they make water. But something else is going to be made too. See if you can figure out what else is going to be made besides water.